Right, here we go, guys. So, we're going to talk a little bit more about comparing the data. So, we've already talked about how we can create those dot plots, right? As well as histograms and even the box or box and whisker plots, okay? So now we're going to focus more on comparing. Okay, so we've got this little task we're going to try first off, and probably kind of have some notes and go from there. So, a lot of information can be obtained from looking at data plots and their distributions. It is important when describing data that we use context to communicate the shape, center, and spread. So, those are the three main things that we're looking at here: shape, center, and spread. So, when we talk about shape and spread, okay, here's kind of what we're talking about. The modes. Okay, remember mode is the one we see the most. So is it uniform? Okay, uniform would be something like they're all the same size. There's basically no mode, right? If it's a histogram, they all go to the same height. Okay, unimodal, when one of them is higher, and we have one mode. Bimodal, with two main ones, or multimodal, which would have multiple where it's a lot higher, okay? Multimodal could look, something like this, where you have a bunch that are up higher than the rest, okay? So looking at that mode is one way that we kind of look at the shape and spread. A skewed distribution, okay, is another one, where it's on one side or on the other side, the majority of the data, okay? Now, normal distribution and standard deviation. A normal distribution kind of has a curve to it. And a fairly decent example is this one right here, okay? That's kind of a normal distribution. It's unimodal, so it has the one mode, and that's generally in the center. Okay, it's symmetric, so as we look at left to right, it's kind of going at the same, roughly the same. Okay, we also have outliers. Okay, those are values that stand away from the body of the distribution, okay? And that interquartile range, we use that to help determine it. And we can use the calculator, remember, to do a lot of this stuff. And especially with the box and whiskers, it's helpful to show us that if there's any outliers, okay? And variability. Values that are close together have low variability. Values that are spread apart have high variability, okay? So what you guys are going to do is using these and also talking about center, okay? And you're going to compare some distributions on the back side of this paper. So analyze the data and see if one value can be used to describe the data set. Normal distributions make this easy. If not a normal, so remember a normal is kind of a distribution where it kind of goes up into this curve and then back down. Okay, is there a center that describes it? When we talk about center, we often use mean or median to help talk about that, to compare the centers. Okay, so on the back side of this paper, you've got a bunch of different classes with data sets. Okay, on scores. So we've got a couple box plots, some histograms, a dot plot, okay? And that's what we're going to spend some time doing, is comparing them, okay? So, first of all, what you're going to do is go through, and here in a second we'll have the guest teacher pause the video, and you're going to describe the data distribution, okay? So you're going to look at each one of these, and you're going to describe, what is its shape, what its center, its spread, okay? And what we're using to talk about that is it uniform? Is it unimodal? Bimodal? Multimodal, okay? So uniform would be something like this. Okay, that would be uniform or even unimodal. Okay, bimodal would be if it has two spots. Multi if it has more than two going up. Okay, is it skewed? Is the data to one side or the other? Okay, and I've got a great picture we can look at to see that one. So if I look at this, okay, that symmetric that uniform, okay, notice how it's kind of symmetric here. It's unimodal, and then it goes down at roughly the same rate, okay? That's a symmetric shape. Skewed to the right, okay, means that the data is on the left side, so it's kind of skewing down to the right. Skewed to the left, skewing down to the left. The majority of the data is on the right side, okay? So that's a good way of seeing that. So you're going to talk about, okay, is it uniform? What modal it is. Skewed. Is it skewed to the left, skewed to the right, or uniform? Okay. That normal distribution, if it's uniform, that's kind of use that. Does it have any outliers? Is it high or low variability? Okay. A high variability would be numbers really spread out. Okay. Whereas a low variability would be numbers really close together. Okay. And kind of compare, does it have a higher or lower mean or median? Okay, that's kind of what we're looking at here. So, what I want you guys to do is spend about 5 minutes looking at each of these and trying to use those words to describe them, okay? And what you think they would look like. Then after that, we'll talk about them, and then we'll have you compare these different ones, okay? All right. And then we'll hand this in so we can talk about it next time in class too. And actually maybe what we'll do is we'll just actually have you guys describe the data distributions and then turn this in, and then next time in class we'll kind of talk about the comparisons and go from it that way. And then we can then we can move on. I like that idea better, so let's do that. So you're just going to describe the distributions. So have the guest teacher pause this, and you guys get describing those using those words we just kind of used. Okay? So if you haven't paused it, pause it now. All right. So let's kind of talk about these. So if we look at Williams's class, okay, first thing I'm going to notice, it's bimodal here, okay, because it's got two modes. Its shape is skewed to the right. It's not looking like I'm really seeing any outliers in any direction, okay, and I would say it's got I wouldn't call the variability high or low, kind of a medium, but I mean, because it goes clear down from 60 up here to 100. So I guess its variability is higher. And if I was to look at the mean and median, the median definitely would, and the mean would probably be, somewhere around here in this range, okay? Because we have fewer scores up here and a lot more down here, which would really pull it down to this area here for its center, okay? So its center is not really in the middle of the data. All right, women's class. So this one definitely is multimodal, okay, because you got like 4 of them, okay, which means this is more of a uniform distribution, okay. It's not really symmetric, okay, not really skewed to one way or the other, I would say, like the one on the left was. Only goes from 70 to 90, so this one has a lower variability. Not as much difference in the scores here. And not really any outliers, okay? Because it's uniform, our center, I would say, is going to be somewhere around here, isn't it? Okay? That mean and that median. We could definitely even find the median, couldn't we? Because there are 6 right there, 6 there, 6 more, 6, 6 and 6. So it's going to be, basically right there that our median would be, and our mean might be a little bit less than that, but pretty similar. Okay, so center right about there. All right, crofts class. Okay, box and whisker. Now, this one right off the bat, we can see there is an outlier right there. So this one does have an outlier. But other than that, it goes from about 60 to 100, so kind of a high your variability. Okay. If we look at this plot, it's kind of got the median, remember, would be right here. First quartile, third quartile, low or high and low. And this outlier would really be the low. But because it's so far beyond, we don't include it. So our median's right there. Our mean might be a little bit higher, just because, from that median, that's half the data. A little more on the right side than on the left side. It's not really skewed anywhere, so it would probably have a uniform, be symmetrical, because the box isn't to one side or the other. Okay. Anderson's class here, we've got a high variability as well. Okay, it goes from 60 to 100. Now notice this shape is more of that curve. Okay, so this would be more symmetric. I don't see any real big outliers. Okay. Our unimodal, right? And probably our mean and our median, because it's symmetrical, would be kind of like crossing these out. So it's going to be pretty similar to being right there in the middle. Okay? Since we don't have the data, we can just kind of guess at that. All right? Hopefully you're kind of thinking some of these things correctly from before. Okay, if I look at Herlia's, okay, another box and whisker. Okay, you can kind of compare it to that one. Again, has a high variability. I can't really tell with these ones what the mode would be, so I can't really talk about the mode. But again, there's our median right there, that center. This one would probably have a mean a little bit further below it, because you've got some more of the data on the left side than on the right side. But it looks like it's probably pretty symmetric. The box, like a non-symmetrical box and whisker, would look something like this. Okay, where it would be to all the data would be to one side, whereas this is more kind of in the middle, right here, as we can see that. Okay, all right, Jones's class. Okay, now this one clear out here, that one could be an outlier. Most likely it is. Okay, and this one kind of seems more skewed to the left. It is unimodal, because it has one that's higher, right? That would be the mode here. But the majority of your data is up here. It's definitely got a high variability. And so your centers are going to be pulled up here and going to be higher, because all these ones would be, taken out by those. And so your mean and your median are going to be more about in that zone. Okay, kind of drags it up higher. All right. Now Spencer's class. Okay, this one kind of has that symmetric shape, doesn't it? So we call it symmetric. It is definitely unimodal. Don't see any outliers. Now notice here, this is at 74 to 86. Okay, where a lot of these other ones, we're going from like 60 to 100. So its variability would have a low variability. No outliers. Symmetric. So your mean and your median are going to be here in the center. Okay, and finally, this last one, high variability here. Again, we can't really tell the modal. very symmetric looking, because it almost looks like this is smack dab in the middle. So definitely symmetric. Okay, that would be our median, so our mean is probably going to be pretty similar to that, because it looks like we have about the same amount of data on each side. Okay, and we don't see any outliers. Alright, so that kind of gives us an idea of, and hopefully just kind of stretched your brains a little bit as you looked about it, did it, tried to think through it. And like I said, when I come back, we will then compare these and talk about those comparisons, kind of a way to help us review and see what we're doing here. Okay, so here's this first one, this first video, and we've got more coming.